So in this next section, we're going to talk about what's called a Pythagorean triple. A Pythagorean triple are just three sides that form a right triangle, but not every three sides are going to form a right triangle. Like if you just picked three random sides off the top of your head, there's no guarantee that those would form a right triangle. But we can test it by plugging them into that Pythagorean theorem. Plugging them in to the Pythagorean theorem. And when we do that, just like when we're checking an equation or something, if we get a true statement, that means that it is a right triangle. Those three side lengths do make up a right triangle. If you get a false statement, it is not. It cannot be a right triangle. And that's going to come up a bunch. And just remember that Pythagorean theorem, and hopefully I don't really think you need to memorize it. I think you get it on the formula sheet, but it's easy enough. A squared plus B squared equals C squared. And just wanted to remind you or keep in mind that these are exponents up here. These little squareds, these are exponents. So don't mistake those for times 2. Don't write them like times 2. Okay, so we're going to use the Pythagorean triple here in this first example. Would the following side lengths form a Pythagorean triple? So they're asking this, does it work when you plug it in to the Pythagorean theorem? So remember that when you're looking at this, the longest / largest, whichever way you want to think about it, the longest / largest side is always C, aka your hypotenuse. So we're going to use that Pythagorean theorem. A squared plus B squared equals C squared. So in this first one, I'm going to use 5 as A, 12 as B, and 13 has to be my C because that's the largest one. So 5 squared plus 12 squared equals 13 squared. And this is where you can be using your calculator with those squares. 5 squared we know is 25. 12 squared we know is 144. 13 squared I think is 169. Yep. Okay, so now we just check the math. 25 plus 144 does equal 169. So 169 is equal to 169, which means that here, this would lead us to conclude that, yes, let's be specific. Side lengths, oops, don't want to die here. There we go. Sorry about that interruption. Yes, side lengths of 5, 12, and 13 do form a right. Well, technically the question is asking me, do they form a Pythagorean triple? They do form a Pythagorean triple because we got a true statement. Boom. So then, let's look at part B, see what goes on in B there. So 3, 4, and 6. So 6 has to be my C because it's the largest one. And then either 3 or 4. Let's do it backwards this time. Let's make 4A. Feeling a little crazy today. So 4 squared plus 3 squared is equal to 6 squared. 4 squared is 16. 3 squared is 9. 6 squared is 36. And I can tell already this is not going to work out because 9 plus 16 is 25. And that is not equal to 36. So here we have no, actually let's use a different color. I don't know why I'm so insane about the colors. Here we go. So no, side lengths of 3, 4, and 6 don't form a Pythagorean triple. We ended up with a false statement. We ended with a false statement. Boom. And that is how you use the Pythagorean theorem to determine if the sides can form a right triangle or a Pythagorean triple. And again, when they're asking about Pythagorean triple here, Pythagorean triple here, they're really just asking, is it a right triangle? It's the same kind of question. You can see it either way.